Hi, so this is our final project for computational thinking. Here's our project overview. We chose project 3 for this. So our project analyzes power consumption data from 3 zones in Tetuan, Morocco for the year 2017. Our objective is to perform exploratory data analysis on power consumption and weather data, build multiple linear regression models to predict power consumption for each zone, compare model performance with and without using libraries, and finally to implement predictions for given weather conditions. So this is where the code starts. We start by importing our required libraries, and then we're reading our data. So here is the first 5 lines of the data we're reading, and this is just to show the data types of each column, and this is just a basic statistic of our data. So here we have the correlation heat map. As you can see, temperature has a positive correlation with all 3 zones, while humidity has a negative one, and wind speed has a positive one too. And then here we have our pair plot, and we can see temperature's positive correlation clearly here, and humidity's negative correlation here. And for wind speed, it's kind of a weak relationship. Like there's data all over, so we can't. It's just a weak relationship. So here we prepare the data for our model. So we have the features which are temperature, humidity, and wind speed, and our 3 zones. And here we are scaling it to standard units so that we can implement it with our gradient descent function. So first we're splitting our data into a test set and a training set. The test set would have 33% of our data, while the training set has 66%, everything else. So this is our implementation of multiple linear regression. We define it as a class, so it's easier to use it for each zone. And here we're using the class to train all our data. And here we have the output. So for zone 1, we get the intercept to be 32,320, the temperature coefficient to be 2965, humidity's coefficient to be -701, and wind speed to be -305. These are the values for zone 2, and this one's for zone 3. We have the model equation for each of them down here. So here is the visualization of the cost function. This one is only till 2000 iterations, and this one's till 100,000. And now this is our implementation of multiple linear regression using the scikit-learn library. As you can see, this one is much shorter and simpler, and we have our values already. And these values are almost exactly similar to the ones we got here, like the one we got from scratch. So here we are assessing our model. This one is the Scratch implementation. So we get an MSC of this, an RMSC of 6359, MAE of 5198, and R square value of 0.2027. So this one is of the training set, and below that we have those values for the test set. As you can see, they are very similar, just a bit different. The same goes for zone 2 and zone 3. Here we have the same values for the scikit-learn implementation. As you can see, we have the exact same values here too. So now here we have the visualization of the predicted power consumption from our function versus the actual power consumption. If this was an accurate function, to like get the weather data, everything would have been on this line. But as you can see, weather it is hard to predict it. Like it is hard to define a function for it. So we do have data all over the place, and that's why our R square value is really low too, like 20.27%, which is really low. So here we have a model comparison of a scratch function and the sklearn function. As you can see, we get this exact same values. The R square score is the same for zone 1, zone 2, zone 3. Same goes for RMSC. And this indicates that it's a strong model fit, like both are compatible. So here is our function to predict the weather. So here for these given values, 12.5 degrees Celsius, 71 humidity, 0.073 wind velocity, we get a predicted power of 29,224 kilowatts. And here in example 2, we just print the dictionary as it is to show how the data is being stored. And here we have the predictions for the given weather conditions from the IPYNB. We have those values stored in this list, and then we have the predictions for the given weather conditions. We have the values stored in this list, and then here we get the predicted power consumption for each zone. This is weather condition 1. So you can see this is the value for zone 1, zone 2, and zone 3. And this is for weather condition 2 and then weather condition 3. So conclusions and recommendations. Project conclusions. Temperature, like from the data we've processed, we found that temperature is the strongest predictor of power consumption. Higher temperatures mean higher power consumption. Humidity shows a negative correlation, but wind speed has a minimal direct effect on consumption. And here is a review of the model performance. Both implementations show excellent and consistent performance. So different zones show distinct consumption patterns, and predictions can be considered acceptable for operational planning and forecasting. So to end it, here are the key results. So we've successfully implemented the gradient descent algorithm and achieved nearly identical coefficients using the scikit-learn implementation as well. And then we've created a function to predict weather. And both approaches produce nearly identical coefficients, so they're an excellent agreement. So for this project, Kamal, did the literary review and exploratory data analysis, and my teammate Nathan Crabtree, he made the model for our project. Thank you.